All right. Guten Morgen, wie geht's? That's about well, I have a bit more German than that, but I won't attempt to do this in German. I'm not that talented. Um, I'm Kevin Carpenter. We're going to be talking about tooling intuition. Uh, my day job, I write credit card software, so when you swipe your credit card, I have software that answers it if you're in the US. My code is not especially complicated. It has things that are old and new, and we won't be looking at the code in this particular talk, but just a little bit about me and what I do for the day job. This is a back to basics talk, and so I'm going to jokingly say if you were in the quiz last night and you understood a lot of that, then you might prefer randomness or something, because this is going over, the goal of the talk is, I was thinking about how I started doing bugs. You're coding something and something comes up, and how do you end up figuring out what that is, and how do we build about that? So, tooling intuition. So, of course, when I started doing the talk, I know intuition is for me, but then I'm like, all right, well, I need to look up and get the definition for it. And, the ability to understand something immediately without the need for conscious reasoning. That kind of aha moment. You look at something, you're like, oh, that's what that is, And I wish I had a lot more of that. And so that was, like I said, I'm going, how do I build on that? We shall allow our intuition to guide us. And I think I think we all end up doing that a lot when we're writing code. And so I wanted to delve into that more. So as I turned around and Googled intuition, of course, I ended up seeing this little graph, and it's small for a reason. And so, being Google and being a developer, does anybody get this reference? The squirrel? Is this more of an American thing? It's like we say squirrel and, oh, look at that, it's shiny. So I clicked on the graph, and I'm like, okay, so intuition's going all the way back to the 1800s, which I figured. But then I'm like, I noticed there's at least 3 points on this graph that are kind of tall, so I started going, well, when was intuition used? And so we'll start with 1877. And so if you Google intuition for 1877, it came up with several points, but intuition is that function of intelligence by which an object presented by the mind itself is apprehended. So, like I was saying, that aha moment, you turn around, you look at something, and you see it, and it just, you know that's what it is, right? But then I'm like, how did we get that many hits for 1877? And as it turns out, I found, as I followed down this chain, William David Ross, father of intuitionism, which I didn't know was actually a thing. He talks about the fact of, knowing something in the same way. His particular view is more of a moral sense. But the part that I found interesting about this quote was the non-empirical or priori knowledge, that idea that you didn't have prior knowledge about it. And I don't know that I agree with that, because intuition is something that's built on, I think, based on our experiences. But it was still, an interesting point. And evidently, his particular book that he wrote did have intuition listed 741 times out of 641 pages. So I think for 1877, he probably, was one of the first people that ever Google stuffed keywords, But, now this is much earlier, but since I'm in Germany, Immanuel Kant. The mere form of intuition without substance is in itself no object, but merely formal condition of an object as phenomena, as pure space and pure time. How many of you love templates? Oh, okay. A few, that's fair. To me, this was like trying to parse a template error as I heard that. I'm like, okay. But then he had thoughts without content or void, intuition without concepts is blind, and I mean, that's kind of deep, but I was good with that. But his favorite quote that he had that I took, which really doesn't have much to do with intuition, is rules for happiness, something to do, someone to love, and something to hope for. So I just had to throw that in there. So we go up to 1967, our next point on the graph. So Googling intuition there, the major role of intuition is to provide a conceptual foundation that suggests direction which new research should take, Raymond L. Wilder. So if I replace the word research with debugging, That's probably what I spend most of my day doing. And so I thought that that pointed well to it. Raymond Wilder also talks about the fact of the role of intuition in research is to provide an educated guess. And I think that's an important part too, because there's a lot of times when we're going through our code and we think, well, I think it's this. And so, you'll kind of work your way down that path and see where that ends up leading to. And that's the part I really liked about the quote was it's like progress cannot be made without it, and even a false guess may lead to progress. Right? Even when we get it wrong, we still get something right, and I can appreciate that. So he also had intuition as used by modern mathematics, meaning the accumulation of attitudes, including beliefs and opinions, derived from experience, both individual and cultural. So the particular paper that Raymond Wilder had here, did get more into or into mathematics. And I thought that was interesting because it's CPPCon, I want to say in 2018, and I was trying to look up the particular talk. I saw a talk where the speaker actually looked at methods, and as you can see, we're going to use contrived examples in this talk, but they looked at methods by the way of mathematical. And so if we look at this method mathematically, a byte's going to be how many possible combinations? I mean, 1 byte. Anyone? 256 bits, right? Okay. Am I wrong? Am I missing it? Okay. Yeah, if I have something wrong, you can correct me. I'm all game for that. So if A is 256 bits or possibilities, and we multiply that by B, we have a possible set of 65,536. This isn't really intuition though, right? This is more reasoning. We reason about the code. And there's a lot of code, I think that, that's one of the big things, at least when I'm writing code, you have to read it, reason about it. In the case of the quiz last night, there was not much that I was reasoning about. But so reasoning, but not necessarily intuition. So, we're to my final end where I was running off on my tangent on intuition, and, intuition for 2019. I mean, with the amount of hits that's there, it's like intuition is now the new in thing. But evidently, it's only in thing for red wine. So, and that doesn't really help us much for our code. Maybe. Okay. So the key points I want to take away from the intuition is that, it's a function of the intelligence. Intuition is the epistemological view that some moral truths can be known without logical inference. The role of intuition in research is to provide the educated guess, which may prove to be true or false. And of course, the rules for happiness, I think, are just good rules for happiness. So when I was getting ready to do the talk, I had asked colleagues to send me screenshots of their particular development environments. And the one thing I thought was interesting is at least all of the people that I work with, everybody likes dark backgrounds. Is that the same here? Is there anybody that uses light? Oh, okay. All right. I'm learning. So, we're doing intuition, and then we're talking about tools. And I think in general, we all use a lot of different interfaces, multiple OSs. I had everybody from Linux and Windows and, Macintosh and Windows on Macintosh and Windows on Linux and Linux on, how that all goes with our virtual machines. But we all use a lot of common tools. There's, a whole handful of editors that we use, compilers and such. And really the thing is that I think when it comes down to it, we all end up at the same problems. So we can turn around and spend some time going through some of those problems. So just to give an overview of some of the, different interfaces, C-Lion, Visual Studio Code. Is anybody familiar with the red C++ logo there? Oh, that makes me happy. So that's C++ Builder. I liked it at one point in time, but they use a version of this STL that is supposedly version 11 compatible. We'll leave it at that. But then we have our compilers, right? So Intel, Clang, Microsoft's compiler, C++ Builder, GCC, and static analyzers. So Clang Tidy or Clang D, if you're using Clang D now, PBS Studio, Reshaper, Resharper, C++ check, Sonar Source. You'll notice I have Sonar Source logo down on the bottom. I just happen to like Sonar Source. I have a slide in here later where I'll show some comparisons, but the tool for their linter works well with our work that we do. Otherwise, I'm not affiliated with Sonar Source. So of all those tools, how well do you use them? And are they doing everything that they can for you? Right? I mean, that's where I want to try to get to. All right. So from my experience, I get 3 types of problems when I'm building code and writing new code. Compile time, syntax errors. I give templates its own category. I do love templates, I'm just not that good at them, and I'm getting better. Link time, you're compiling something and suddenly a symbol cannot be found. I put missing libraries and versioning issues because I've experienced, those when we are building such. But of course, that's where I'm citing 3 types of problems at least. And then runtime, your logical errors, semantic errors, and various other types of errors. I mean, that's, I think, where we spend most of our time debugging things is when we're in the runtime and you're outside of this code being able to be analyzed. So this was me in the 90s. This is Turbo C++. And I wanted to show this because if you're new to programming, then when you get an error, at least for me when I was younger, and even now still, you can kind of see, and sorry for the red there, but you'll notice that I got the cursor there by the semicolon in our method. And so, I'm going to do the simplest error we have, which is to remove a semicolon. Now, back in the 90s, if you removed a semicolon, and this is all in one file, if you actually had a semicolon removed in a file that was included in a file that was included, then this list went even longer. But basically, missing one semicolon from an old compiler and suddenly every line of code you had was wrong in some way. And yeah, my younger me, this was a little bit, really, where am I going to start? Fortunately, we've gotten better. And if I put the semicolon back in, of course, it does build and run. If anybody wants to run Turbo C3 on your Windows box, you can actually download it. I did it just for this. I don't think I'll open it again, just saying. But that's what it was like to code in the 90s, at least for me. And so we'll look at something newer. So you'll notice I'm guessing if you're in the back, does the font come out all right? Okay. So we're going to look at the same kind of an error. You can see I'm already missing the semicolon. You'll notice that I have the Compiler Explorer logo. So later on, you'll be able to get a QR code if you do want to download the PowerPoint slides. I did try to make sure to link everything with Compile Explorer so you can actually look at the code samples. But the thing we're going to go through over the next few minutes, well, next half hour probably, is different compilers and options and what it ends up giving us back. Because again, my thought was, how did I build an intuition for when a bug happens? And from where I started back there with C++ in the 90s, our error messages have gotten better, but it all depends upon what you're using and what version you might be on. The job that I work at, when I first started there, we were still stuck on C++ 11 with, Clang or with GCC 4 at the time. And so in this case here, if we compile this particular code with GCC 4, we get the fact that we're missing a semicolon and that it needs to be before the return. Okay, so if I didn't do C++ in college and I decide to put it before the return, right, I can do that. And it does work, right? I mean, that's, and so that was GCC 4. Of course, now, if we even take Clang, so Clang 3, this is an old version of Clang, right? And so one of the things I was always told was that Clang, when it first came out, was being built a lot for its tooling. And And so if you take that same code, it at least gives you, hey, you don't want to just put it in front of the return, you actually want to put it at the end of the line. And so I get this as, this is where I'm like, they are kind of contrived examples, but my bigger point is that the tools that we pick matter, and what you end up doing with the tool can get you more information. So when you're starting off learning to develop in C++, you want to use the best tools you can get. And best might be a little bit of a loaded statement, but I think you understand what I'm saying. Go with the newer tools. If you do the same thing in Clang 17, now they'll actually give you the line numbers and some nice layout. And so, again, these are small examples because I was trying to make sure we could fit things onto slides too. But I think you see the point where we're getting there. And GCC has actually gotten better. If you're using a modern version of GCC, you get roughly the same. And I think that's also interesting because Clang and GCC seem to have started to catch up with each other from their output. So Jason Turner has his Hello World, and I heard someone say it's the most complicated Hello World that they've ever seen. So this is using features, sorry about that. This is using features of C++ 14. So if we try to compile it in Clang, we end up getting an error because of an expected expression. Even using an old compiler, if you make sure that you're using your compiler options though, then it compiles and works well. So that covers our basic syntax errors. We'll leave it where that's at, and we'll move along to templates. And so I'd asked this question before. Some of you really love templates. Actually, we should all love templates, right? Because if you use any standard library, you're using the templates. And I don't necessarily write as many templates, but I use the template library a lot. So template errors. Does anybody see what the error is going to be in this? Yeah, a couple? Okay, all right. So the point I want to make is there is a very small error, but that's the start of it. And it actually, it goes on for about 300 lines. So this was why I never liked templates. And actually the company where I work at, for some of the people that originally, for an old guy like me, when I started when we didn't have templates, I always wanted to avoid templates because I would get an error like this and I would probably turn whiter than I already am. Like, oh no, what am I going to do? But how do we break down, what's going on with an error that's like this? And so this is with GCC 4.9. I left, as I'm adding compiler options, they will mostly stay in because I just want to keep showing that, you want to make sure you're using the right options when you're compiling code. So if we take Clang trunk and we compile that same code though, it's still going to give an error, but now we actually have something of value, right? Because here we're, as I'm reading through this, it's like, okay, invalid operand and binary expression. So that's still, it's better than what the other one was, right? So out of curiosity, does anybody know where we're using a binary expression in those 3 lines of code? Yeah. Yeah. So when we're doing the compare, you have a binary expression, of course, because you're looking for the equals. And as it's pointing out, the values don't match. And if we look there, it even tells us that the std vector int and const int are the 2 that don't match, right? And so compiler errors, if you're actually using a more modern compiler, you can get better output and thereby make it easier to fix. So all of you use WAL? Yeah? Okay, I see. Do all of you use WAL? No. Okay, a lot of people do, that's all right. I didn't for the longest time. When I first started with our company, we were not the warnings and errors are all on all the time. And so, but with template errors, it's helpful. So if we do the same code again and look at it, well, that just proved me wrong. We get the same looking error there. Sorry, they're having an error in a slide. But if we look at, sorry, I have a duplicate slide there. I apologize. But with WAL, we actually now get, an even more, the variable A is uninitialized first. So because we're doing WAL, we're getting all the warnings. And so yes, it is uninitialized. But it's also telling us on line 7 that the std find is where the bulk of our problem is at. And so this is why you want to be using all of your compiler options, because that error that was so scary to me before, this actually gives, the compiler does so much more work for us now than it ever used to. But if you're not actually turning these things on, then you're not going to know. And have the compiler help you, I guess, is more to my point. And so as that points out there, it actually tells us that exactly what the invalid expression is. And so we have clear detail of what's going on there. And so yeah, if we turn it into a std vector, now of course it compiles fine and the problem is solved. So template errors don't have to be so scary. If you use the tools that you have, then you will be you'll be thanking yourself. And when you're doing stuff just in the standard library, because that's my point, it's like, if I actually write a template, then I create far more errors than, even what the template library there does. But the compiler can make all the difference that way. All right, so everyone should WAL, WExtra, and Pandantic. The amount of options that the compilers have is just huge. I think it's probably 10, 12 pages of options. And so that link there is the link to the actual warnings for trunk. But for me, WAL, WExtra, and Pandantic, there is, always have your warnings become errors. When we're doing something in production, I absolutely do that. I think it's a good thing to do. But even if everybody just uses a couple of these, my goal is to help you improve your code that little bit. And so even if the first step is just adding WAL. Pandantic does C++, the compiler extensions. And so Pandantic, we end up using it. If you're ending up moving your code between different systems, then Pandantic can help make sure that you're not using an extension on one system that is not available on the other. So I have it listed there. It's your mileage may vary. And so I was reading a C++ Reddit where somebody's like, what compile options should you end up having? And they were saying, in fact, everyone should go to this particular best practices. So Jason Turner, as I pointed out, he has that nice obfuscated hello world. He also has a best practices where he goes through and lists the different compiler options to use. This particular site also has some CMake setups and such like that. So if you haven't done a lot of CMake projects and you need boilerplates, that is definitely a good place to check out. Boy, everything that I had hidden is suddenly showing up. So has anyone seen this talk? I know Phil has. So I picked out, so Bryce Labaki works for NVIDIA, and he did a talk that's AI-assisted software engineering, and I'm putting this slide in here specifically. One, Bryce is actually pointing, asking him to turn down the lights, but I like this particular shot in the slide because I'm like, Bryce is pointing to the future. So they have a project called CY. So talking about templates, for AI-assisted software, how many of you used like Copilot? How well has it worked for you? Yeah, so I do recommend you go see, you watch this talk, because at the same time, how many of you get your code right the first time? Right? So that's kind of his point. We want AI to be right the first time, but yet, we seldom do. But the reason I wanted to put this in here is him and a couple other people worked on a tool called CY, and CY will take the output from the compiler and help you figure out what went wrong. And it can even go into the fact of being used inside of a CI/CD chain and actually suggest patches and such like that. So if you want more exciting ways to work with your templates and your errors that you're getting out, I would say check out that project. All right, so syntax errors, templates, we've got those couple covered. Let's move on to linkers. So linking errors, missing libraries, versionings, and basically cannot find symbols. How many of you get that part when you're compiling something and, so let me just go with the example first. So linker errors. So again, a contrived example, but it's going to give us the part that we want to see. So we have a struct. It's got a pure virtual destructor. We have another one that is inheriting from it. You have an extern for x there, a void foo. When that gets compiled in an old version of GCC, it actually works. It compiles clean. It doesn't really run. And obviously this isn't doing anything, but the point I'm trying to make is that you're using an older compiler and it actually compiles and links. If you end up using a new compiler with all of our fun stuff turned on, though, you're going to get a different output. And so you end up getting the fact that you have undefined references. Okay? So do all of you understand an undefined reference? How many people from a show of hands have and dealt with and have an easy time with undefined references? Okay, so an undefined reference. So when we're building code, and there's some great talks that are about how the compiler works, you have two stages, right? You have the compiler that does its compiling of the code to make sure that it is syntactically correct and creates an object file. But then what ends up happening is the compiler will take each of those object files and link them together. So if it can't find something, then that's where we get an undefined reference error. So basically, an undefined reference error is saying, hey, I know you're telling me to call this function, but I can't find a definition for it. And even when something's in the same file, that can happen. Because in this case here, x is marked extern, right? So we're not actually defining x, we're just saying that x is an external variable. So it'll still compile clean, but it actually can't find x. And similarly with foo. Foo, we have not a definition for it, but a declaration for it. And so this is meant to be able to show the fact that if you turn around and have, have you ever had a parameter off? When you have two files, you have a parameter missing in one. And so when it goes to link, it might compile fine, but you end up getting the compiler error. How do you solve these? For me, I end up having to turn around and walk through, the particular lines of code, kind of like we just did, and say, okay, so if the file is saying that it can't find it, what is it trying to link to? What file is not being included? This is actually, in hindsight, as I'm talking about, this is kind of a bad example, but normally when I'm getting errors like this, I did a project in my last talk, where we're doing lib HTTP and JSON, and I was building it on the Mac. And so if you turned on HTTPS on the Mac, it's kind of complicated when building it. It wants a specific version of the SSL library. And so when we get errors like this, sometimes the best thing that you're going to end up doing is falling down the rabbit hole and starting to dig through and ask questions. You know, whether you're searching for the particular error directly on Google. I mean, how many people spend hours on Google copying and pasting an error in to see what they can find? Yeah. But what does that end up doing when we end up figuring it out? That ends up building that experience, and so then the next time you get it, it's not quite as bad. And so in trying to pull this part together, that's where I'm like, we're trying to build an intuition over time. And unfortunately, as much as we want to have that intuition just hit us and happen, like always be able to see what the answer is and know, sometimes it's just the fact of the struggling through it. So with Clang, we get a little bit more detailed information, but it's still the same part, and it fails with an exit. The undefined references, again, when you have that, then you know that you're missing a particular method, and it needs to be able to be called. All right. So link time errors. I don't run into do many of you run into link time errors more, or your compile time errors? Compile time? All right. What about runtime? Nothing happens at runtime, right? I mean, it runs on my machine. So runtime errors, what the compiler doesn't catch. So I have logical errors and semantic errors, and we're going to look at an example that's semantic first. But all of these particular types of errors, they're the harder ones because the code looks right. It compiles. The compiler's not really telling you anything to help you out with it. So we have this particular method here. Excuse me. And I want to take a look at it, and I want to see if anybody can kind of take a bit of reasoning about what kind of error we might get. So if we compile it, it compiles and runs, but the program returns 0 with the product of 0. So it is not actually, getting us the product. It's not multiplying through the numbers 1, 2, 3, 4, and 5 and putting them together. But why? So all right, well, if we take Clang trunk and we do the same compile with our wall and extra and all of our compiler options, so product's not initialized. So on one hand, I'm saying runtime errors are hard to find, but the compiler difference actually pulled that out for us, right? And so, when you're first learning, some of those errors can be caught because the compiler, the compilers have gotten smarter. They can turn around and say, hey, this particular item needs to be initialized or this isn't being used. So the best way that I've found to find runtime errors is test cases. Anybody here use catch? So, yeah, Phil uses catch. So So these are actually test cases that I have from, this is actually test code that I do have from work because we use a lot of binary coded decimal in Visa transactions. And so I do find it easier when I'm getting something that is not actually producing the result that I want for me, it's easier to debug this small test case than it is to necessarily debug the app, right? Now, unlike Phil, I have not fully mastered the part of test-driven development. So I do end up writing a lot more code, and then we write test cases after, and I do need to improve on that. But when you have an error that is, you're having a hard time reproducing, I think one of the best things that we can end up doing is turning around and using a test harness, such as Catch, to be able to turn around and go in and write a specific test case so that then you can look at each one of your particular methods and make sure it's at least returning the result you want. I don't have it included in this slide, but I started off with these particular ones because when you do binary coded decimal, we're actually taking 2 decimal numbers and compressing it down to 1 byte. And so that's what this code is testing for. But then we also turned around and created a method that randomized the amount of numbers that were being passed in and did a bit more fuzzing. And the more advanced tests you generate, we actually found multiple errors in our original algorithm because you ended up hitting edge cases. And it's always easy to test for the one known case, but the edge cases end up becoming harder to find unless you start throwing in random data. And interestingly enough, how many of you actually saw Phil's talk? Okay, so for Phil, that was half the room. So if you haven't seen the talk, you want to watch the talk. It's really good. But Catch 2 has a lot of great features, including a generator feature, which then allows you to build that particular data out, and it can help you find those test cases, those edge cases. So those are our 3 kinds of errors, that I've found and had to work with and build against: compile time, link time, run time. And I wanted to turn around and, it's kind of funny. I'm looking at the clock now and I'm running really short or really long on time. But then at the same time, when I was going through and practicing, I was going slower. So I'm obviously speaking and moving faster. So static analyzers. How many of you use a static analyzer with your code? Okay. So which is your favorite? If you mind, just Clang D, Clang Tidy. How many are actually using Clang D? I'm curious, specifically. So if you use Clang Tidy, and as I understand, Clang D will work with all kinds of other editors. The NVim that was shown as the IDEs were popping in, I like Vim, but I use a mouse. I'm happy with a mouse. But Clang D will actually give you these kinds of errors live right in your code. As you're moving your mouse over the top of a piece of code, it'll tell you when something is wrong before you ever have to hit compile. Clang Tidy, I think, does a great job as well. But the thing that I wanted to show here, which I thought was interesting, is that don't just use one. Because, I actually use the Sonar linter and Clang D at the same time. And as we're looking here, there's actually, there are some things that Clang D and Sonar pick up on the same way. And maybe they talk about them a little different. But then there's a lot of things that Sonar picks up on that Clang D doesn't. And my intuition on it is that, and not actually just intuition, but understanding how Sonar works, they're actually trying, that's their slogan is clean your code, or, if I believe it's along that lines. And so that's actually what they're doing, is they're, pointing out areas of code that should be cleaned up. And all of these can be, everything's configurable, right? At least for us, our Clang Tidy, there's a lot of things that we turn off. I do understand the point of you don't want too much noise, but I think when we're learning, I'd rather have a false positive than, than missing something that is an absolute negative, right? So our compilers matter. Clang, as I've kind of showed in a few of those examples, generally does a good job at reporting. We use both compilers every day in work. If I build something in GCC, I also then turn around and build it in Clang, because Clang will actually give me different results and error messages than what GCC does. Use the newest compiler that you can. We're still stuck to C++ 17 where I work, but we still use the latest, and we just turn around and put the standard line in so that we make sure we're not using something that we're not supposed to, and that we're being compliant with the code that we're supposed to write. And even older compilers, as I was showing when we were going and you added the std 14, if you're stuck on an older compiler, then, again, use your command line arguments so you can say, hey, this is the standard I'm trying to be at. And so add your compiler options. When I started and put together the abstract for this talk, I had planned on doing more with Microsoft Visual Studio. How many Visual Studio developers do we have? Wow, okay. Well, I greatly apologize. I think when it comes down to the error messages and stuff, we see a lot of the same things. But I will say, in my previous position, I used Visual Studio and MFC a lot. I don't miss MFC, I will say that. But Visual Studio, has some great, I love Visual Studio. I really do. I just don't end up using it every day. But some of the same things that we're talking about, it's like the compiler options, they're named differently, but they're all there. And at the same time, if you're using Visual Studio, a lot of these things, they're just on by default. I think Microsoft does a good job, even with their static analysis tools, and they have it wrapped in well. Incidentally, I will say there's one thing that I miss when I'm on Linux, and with any IDE that I've seen in Linux, the wonderful thing you can do in Visual Studio, if you're going through and doing debugging and you have a std string, you can actually change that string while you're running, right? Which is not something that you can actually do inside any of the GCC or Clang. So you can change numbers, you can change, other variable types, but std string is one of those ones that you can view, but you can't go through and change. And so I talked to C-Lion, if somebody wants to fix that, I will change my editor, that's for sure. All right. So this quote from Albert Einstein I really like. It's not that I'm so smart, it's just that I stay with problems longer. I can think of days where I've spent literally days looking at one particular error, trying to figure it out, and writing one small test case, or writing another piece, or pulling out a piece of sample code because you're just trying to dig through it, hours on the internet. And so every time that we end up building through and sitting through those things, though, we all learn that little bit more, which makes the next bug that much easier to get through. So I plugged Jason Turner a few times here because I do think that he does a really good job. If you haven't seen his CPP Weekly, he does some great job at going through and explaining various features, whether it's a compiler feature, code reviews, basic projects to start off. For the half the room that's doing Microsoft Visual Studio, it is standard C++, but he is a bit more on the side of the Linux and compilers such there. And so, yeah, we can all work on building our intuition, use every resource you can, and if you have any questions, let me know. Talks are not always my thing, as that hasn't shown up as being obvious. However, I work as I'm speaker liaison at CPPCon, and I do volunteering for these other ones. The QR code there is just a link to the slides if you end up wanting to get any of the links in there. If you are interested in any of these other conferences, whether volunteering or you want to submit a talk, by all means, let me know. I will say the one thing that's great about submitting a talk, it is nervous, depending upon if you like to speak or not getting up here. But even Kevlin was saying, you know, the way that he ends up learning something or learning more about something is to give a talk on it. Because, you know, where you start in a talk and sometimes where you end up, it's surprising. And then, you know, in hindsight, I still have a whole bunch more slides that I was working down to be able to add here, but you're trying to figure out what content you can fit in. So give a talk. Thank you. And we have plenty of time if anybody does have questions, by all means.
Hi, thanks a lot. One thing I'd like to add regarding template error messages. Do you know about Camilla, script from Vittorio Romeo?
No, I do not.
Because this script can greatly collapse template error messages into readable types again. So it will de-expand something like basic string of char traits back to an std string.
Ah, okay.
And will just basically get rid of 90% of all this mess that the compiler outputs.
That's excellent. I will make sure to get a look at that. And if I end up doing the talk again, I'll make sure to add a slide for it too. Thanks. You.
So we got an online question here. What is the difference between Clang Tidy and Clang D? From the name of it, I guess both would be LLVM and free.
Yes. So both are LLVM and free. The difference is Clang Tidy you run separately. So a lot of the code editors like Visual Studio Code, before we started using Clang D, you could turn around and set up a build job so that it would run Clang Tidy and it would give you that same output. Let me just scroll back here to this slide. 1 second. So this output here is what Clang Tidy would end up doing. And you can see it marked there, you know, Clang Tidy found a particular thing on line 85, column 11. Clang D is fully built into the interface like IntelliSense, I'll say on steroids, because I haven't used IntelliSense inside Visual Studio as much anymore, because like I said, I'm not in Visual Studio, but at least with Visual Studio Code, IntelliSense is nice and it'll help you find, you know, a particular function or method, but Clang D basically gives you Clang Tidy live all the time. So if you type something wrong, it's going to turn around and tell you right there and then in a pop-up box, at least in Visual Studio Code, that this is exactly the error that you're having. So Clang D is interactive, Clang Tidy is a run and get result. That's probably the way I'd explain it. Anything else? All right, thank you.